We're here at GoToMath.com. Click on the calculus. Let's go down to the volume using the disk method, and I believe this is what we're going to be working on here. Okay, so this looks just like 5.1 actually, and there was a statement that I made in 5.1, and that is we found the volume if the shaded region was on the inside here, right? We found that volume, and I think I made a statement that this inside volume would be equal to this volume here. We're going to take this, just this shaded region, and revolve it about the y-axis. We get something that looks a lot like a bowl. Would look like a bowl with, of course, this right here would be. Question is, would there be a hole in the bowl? A hole, and how? What would be the radius of that hole? Think about it. All right. Let me know. Send me what you think about that. If we revolved this shaded region around, we get a bowl. What is the radius of the hole of the bowl? All right, that'd be a different question there. Anyway, it's actually quite interesting because we know at the origin the thinness of the hole is got a thinness of 0. So that's really kind of bizarre. That's a good question. I don't really know, to be honest, but let me know. Find the volume of the solid formed by revolving around the y-axis. Let's write this down. Let's see what we got going on here. Now, we found in 5.1, we found the volume of the solid, the inside stuff, if it was revolved around, looked like a bullet of some kind. And I made the statement that that volume is equal to the volume that we're about to find here. And it just doesn't seem like, it seems like this would be less. For some reason, it would be less than this volume here, but I don't know. The mathematics shows that it's the same. Now, the way we're going to end up doing this is we're going to do this in two separate integrals. In fact, we're using technically the washer method, where we find the outside, we do an outside cylinder, or we do a large cylinder, and then we do this one here, the inside, and subtract off. We subtract off. So, okay, well, let's just go to the whiteboard and check that out. So let's write down what they gave us. F of x is equal to x squared over 10. And we're going from 0 to 10 because it just makes things a whole lot easier. Alright. And we'll go ahead and sketch this up. Now remember, we're revolving around the y-axis here. Alright. So this guy right here. Now the question is, what is this value right here? Right, so that's what we need to know. Now remember, this is the domain, or this is our, our domain we're working in, from 0 to 10. So 10 is right here on the x-axis, and we need to know what is this number here, because that's what we're going to be integrating to from here to here. And that means we're going to be going from 0 to whatever that is. Well, I'm going to rewrite this. Instead of writing it in this notation, I'm going to write it out like this: x squared over 10, right? And then plug 10 in to this, and we get 10 squared divided by 10 is 10. So this is obviously 10 right here. So we're going to be going from 0 to 10, right? Now, we're going to be doing this with respect to dy, so that means we need to go ahead and solve for x in this problem. So we have 10y square root is equal to x, equal to x. Alright, and you're probably right. Why don't we write plus or minus? Okay, that should be a question. It should probably come to your mind, maybe. 10y. Now remember, this is the radius, and it is squared, right? The radius, and it is squared, but we can rewrite that. But we'll do that here in just a second. Actually, okay, got ahead of myself here. Alright, so I got ahead of myself. This, right, is the problem we did in 5.1 where we're finding that would be this shaded region right here, right? But we want to take the larger region, the larger cylinder, okay, and then subtract off the smaller one. Then subtract off the smaller one, okay, my lovely drawing. And that means that we need to actually find this one. Well, this is pretty easy here because this just out is a constant of 10 all the way across, going to 10, okay? So I'm going to say a comma here because, and we're just going to do this from 0 to 10, and remember here's our pi out here, and of course this is a constant 10, so this just becomes 10 squared. That would be our function. And then of course we're doing dy. We're still doing dy, okay? Now it's the larger one minus the smaller one. So in other words, we need to write it like this. From 0 to 10, I got ahead of myself on that, dy minus the smaller radius from 0 to 10, and that's going to be this guy right here, and we'll go ahead and still write that square root dy. Okay, now since we both have the same limits, right, we both have the same limits, we can actually combine this into one single problem, or I should say into one single, we can combine this into one single integral. And you know what, I'm going to actually do that. 0 to 10, so this is 100, right? Let's just go ahead and do that. Minus, and if we square a square root goes away, so this just becomes 10y. Okay, and I almost squared the whole thing, but we don't want to do that. Alright, and then dy. Okay, so we just combined it all into one single integral. Volume is equal to pi, so let's go ahead and take the integral of this. So this is 100 y. Now remember, I'm writing y here, not x, because it's with respect to y, minus 10 y squared over 2. Yeah, I don't know, something fishy's going on there. 0 for some reason in my mind. Okay, and we're going from 0 to 10. Okay, going from 0 to 10. Volume is equal to, so we got 100 times 10 minus 10 times 10 squared over 2. And then we plug 0 in, we just end up getting 0. End up getting 0 out, right? End up getting 0 out. Volume is equal to, now if we weren't, I'm going to go back to 5.1 here real quick, where we were finding just this volume right here, right, revolving this region around the y-axis. Well, that would just be this guy right here, wouldn't it? Right, I want you to look at this, 10y, 10y squared over 2. So that would just end up being this. Okay, so what actually is this? This is 10 times 10 squared, which is 10 to the cube. Let's just write that over here. 10 cubed over 2. 10 cubed over 2. Okay, writing that down. Now, I want to show you something here. This is 10 times 10, and that's 10, so this is 10 cubed, isn't it? Minus, this is 10 cubed. Right? And if I took the 2 and brought this up over here and then wrote everything a 2 under here, like that, looks like 210 there, but that's 10 times. Now if we were to simplify this, we end up with pi times, So these two terms are the same. I should actually write a pi over here too. This was this guy. I want you to look at this. What did we end up with? We ended up with that, right? So it turns out, we just proved this, even though it doesn't seem right, but it is. We just proved that this bullet, the volume of the bullet, is equal to the volume of the dog dish. With question is there a hole at the bottom of the dog dish? But anyway, um, so that's a trip because I would actually think that this volume be greater than that volume. I know that area is greater than that area, I think. I'm pretty sure. Sure the heck looks like it to me. Anyway, that's it. There you go. What is that anyway? Does anybody know? I know 2 goes into 10. 5 times 150. 150. 150. Whoops, divided by 2. About divided by 500. What the hell? 500, not 150. 500. Anyway. 500 pi. So you should be able to derive up some general formulas, and you do that by just plugging in variables, right, into here, but I don't know. I don't really do that. We just try to work through the basics. I'd like to do a lot of that stuff. And why did I just do that? I hit the home button. Can't believe I did that. That irritates me. Like, you don't even know. Why did I do that? Gosh darn it. It was a 15. Oh, darn. No, it was a 10. What did we just get through working? A 10 or a 15? I'll never get 10 to come up. Oh, there was 11. Wait a minute, was it 10? No, 10 was in the last. 10. Come on. What's the probability of a 10 coming up on that one? Next one. Alright. It doesn't look like it's going to happen. Crud. Can't believe I hit the home button. Man, this is like playing roulette. 10 will probably never come up. Oh, there it is. What was the answer? 500 pi? Answer. Yeah, okay. Man, that's craziness. Now, actually, what's interesting is we go back to 5.1. Is this 5.1? Yeah. Look at that. Isn't that beautiful? Wow. Anyway, hopefully my math is correct. I mean, I checked all this stuff over and over again. We're here at GoToMath.com. If you think there's a conflict, you let me know. All right, well, for right now, that's it. We got to move on to the washer method. No, to the shell methods. Okay? And giving a shout out to all the people in Hong Kong for being the most visitors, well, them in Turkey, on the website this week. All right, bye.